So find the missing length of the leg of the right triangle pictured below. So it is telling us this time that it is in fact a right triangle. So I'm going to put the right angle in right there. Now this one, these triangles are all oriented the same because it's too hard on the computer to try to change the orientation. But just understand that they could rotate this, they could flip it up or down or diagonally, whatever. But this is what we got. And they said we are, in fact, trying to find a leg, which is going to be this length right here because it doesn't have a number. But what I do have is my first leg at 16, so I'm going to put it here. Now again, if you want to, for some reason, you make it the second leg, that's fine. I'm just not going to do it. And then the hypotenuse, which is the length of the triangle, which is not making the right angle. So one length, two lengths making the right angle. This one's not, so it must be the hypotenuse. The hypotenuse is 25. So if I were to take that leg that I have, the 16 and square it, and the 25 and square it, well, to finish off that Pythagorean theorem, we would add the other leg squared to get that 25 squared with the 16 squared there, okay? All right, so this is what I got. Now, I don't have my squares memorized so well, so I'm going to go to a calculator and figure out what these values are. So if you're wondering how to put in the power of 2, it's just that x squared button, one button to the left and up from the 7 button. So I'm going to start by evaluating this. I'm going to do 16 to the power of 2 in my calculator. And it says, all right, 16 to the power of 2 is 256. Nice. Now I want 25 to the power of 2. So I put that into the calculator, and then I write in 625. Okay, so my new equation, after evaluating that stuff, I now have 256 plus a leg squared equals 625. So that's a little bit of order of operations kind of stuff. But now what I would like to do is solve for x or leg squared. So at this point I need some principles of equality. So that means I'm going to do something to one side, but if I do it to one side, I must do it to the other side. And no, I'm not going to take a square root yet, because if I were to square root this side and this side, it's going to be really jacked up, which we don't want yet. So what I would like is to take that leg squared and just be able to drop it like this. Okay, and that way it's all by itself, meaning the 256, notice I don't want that here with it. I don't want it here either. So I'm gonna get rid of it by zeroing it out. So minus 256. If I do it to one side, I must do it to the other side as well. And once again, there's no expectation that you do this by hand, although you can if you'd like. You have to borrow for the ones place and also the tens place value. But I just go to my calculator and type in 625 minus 256, enter, and I get 369. So the leg as a square would have an area of 369, but I don't want the area of that square. What I would like is just to know the leg length of that square, the side length of that square. So this is leg to the power of 2. I want it just to be a regular leg, so I'm going to have to go in there, take that leg, and square root it. That leg to the power of 2, but if I do it to one side, I must do it to the other side as well. So in my calculator, I type in the square root of 369, square root 369, enter. Now my calculator gives me this number. Okay, this is the value that I got from my calculator. Thank you, calculator, because I didn't want to do that work. But what it says up here is that we need to round to the nearest tenth. So my leg, I'm going to need to round that value, 19.20937.271, to the nearest tenth, which is this place value. Immediately to the right is a 0, so the 2 will remain a 2. And then my leg equals my final answer. I'll make that bigger. It's going to be 19.2. No label, because we don't know what the units are that are being used here. So I'm just going to keep it as 19.2.